Good morning, students. So in this video I'm going to discuss about a very important topic, and the topic is the first law of thermodynamics. And based on the first law of thermodynamics, lots of applications are also there. So what is the first law of thermodynamics? So if you see the definition is that the first law of thermodynamic, the, the change in internal energy of a closed system will be equal to the energy added to the system minus the work done of the system to its surrounding. So this is the formula for the first law of thermodynamics, and this law is the conservation of energy. So what is this du? This is the internal energy. I already discussed about the internal energy, so please go through these lectures or videos. What is internal energy, you can understand. So, then what is this q? Q is the heat energy. Heat energy, it means the heat that we supplied, and the remaining this part is work done. So internal energy is equal to heat energy plus work done, or we can also write it like this. mm, just one other, like dq equal to delta u plus w. So this is basically heat that we supplied, heat energy. So when you supplied heat to any system, then it may work, and this is its energy changes. So this is the internal energy. So already we discussed that internal energy means the potential energy plus kinetic energy. So it is obvious that when you apply heat to any object, it changes its energy, internal energy. It is a combination of potential energy plus kinetic energy. Then this is the work done. Okay. So this is basically the first law of thermodynamics. So we can write it like this in precise way: dq equal to delta u plus w. So this is our heat energy, this is our internal energy, and this is work done. So when we applied any heat to any system, its internal energy may change, and also we get some work done. So by definition we can write that first law of thermodynamics is based on the principle of conservation of energy. Okay, so this is totally based on the principle of conservation of energy, this formula. Okay, also we can write that it says that heat energy given to a thermodynamic system is used for change in internal energy and work. Okay, so we can also write that du equal to delta q plus minus w. So this is our uh, brief definition of the first law of thermodynamics. Now we can discuss some application, mathematical application based on the first law of thermodynamics. So just I'm writing here some, this is just mathematical terms. You can write application of first law of thermodynamics. Okay, this is the heading. So there are basically I'm discussing the two application. First is molar mathematical, this is a mathematical expression application, molar specific heat at constant volume. Okay, molar specific heat at constant volume. So we can write uh, for 1 mole, for 1 mole molar specific heat, we can write it just like this, Cv at dt. Okay, so we can write like this for 1 mole. So we can write like this, q equal to mst. So this formula we can get from specific heat formula. Okay, so this is this formula we can get from the specific heat formula. So we can write this for 1 mole is equal to, for at constant volume, is equal to 1 dot Cv dt. So this is for 1 mole. Okay, this is for 1 mole, and this formula we can get from the specific heat formula. So now we can write using the first law of thermodynamics, this d equal du plus w. Okay, so here the condition is that it is the volume is constant. Okay, this part is constant, so we can, this part we can write also like this, p dv. So how we get this work done equal to p dv? So we know that w equal to force into displacement, work done equal to force into displacement. Okay, so this part we can also write into displacement by volume. Okay, so we can write p into v. So we can also write it like this, if it is dw then p dv. Okay, so we can convert our w equal to p dv using this formula. So this is the constant volume, so we can write no change in volume, there is no change in volume, so it means our this part is equal to 0. Okay, our this part is equal to 0, therefore we can also write du equal to dq, and what is the formula value for the dq is equal to 1 dot cv dot dt. Okay, so this is for constant volume. Okay, so the first application we can get du equal to, this is u 1 cv dot dt for constant volume. So here we can use the specific heat formula. So this is the specific heat formula, then we can put the value into this formula. Then using the first law of thermodynamics, this is our first law of thermodynamic, and here there is no change in volume, that's why you can, this part is 0, so we can get du equal to 1 Cv dot dt. Now the next second one is at constant pressure. At constant pressure. Okay, so this is almost same as our constant volume. Okay, but here we can take the pressure is constant, so we can write at constant pressure Q equal to, same using the formula for specific heat, molar specific heat, then our dq equal to 1 dot cp dot dt. Then what is the formula for work done? We also know dw equal to p dv. Okay, this is work done. Now next our work is applying first law of applying the first law of thermodynamic. We can get dq equal to du plus dw. Okay, so our, in that case, dq equal to cp dt, and du already we know from our that formula cv dt, and this is p dv, so we can give the equation number 1. Okay, so here we get cp dt, cv dt and p dv. Now next step is cp minus cv dt equal to p dv. So ultimately we can write cp minus cv equal to p dv by dt. Okay, so we can give this equation 2. So from that part we can get constant volume, and here this is the cp minus cv equal to this. Okay, actually we are going to calculate very important formula using this thing. So next is for ideal gas equation. Okay, for gas equation, we can write pb equal to RT. I think all of you know this equation. Then we can add p dv by r dt, differentiate. Okay, so next we can write p dv by dt equal to r, so we can give equation 3. So if we see our equation 2, what is our equation 2 that we used here is equation 2 is cp minus cv equal to p dv by dt. So this is our equation 2. So it means our this part is equal to cp minus cv. So I can write it here on the term cp minus cv, and our this part is equal to r. Okay, so we can derive a very important formula, and this is known as, this is Maer's formula. Okay, so this formula is very much important for the upcoming exam also. Using the first law of thermodynamic, we can derive this formula. So I think you understood what is the first law of thermodynamics. The first law of thermodynamics basically is based on the principle of conservation of energy, and it says that the heat energy given to a thermodynamic system is used to change the internal energy. It means after using any heat, this is the heat, this is our internal energy, and this is W. So when you applied any heat to any system, its internal energy may change and its work done may also change. So it means our heat energy is directly proportional to the internal energy and work done. So based on this formula we can derive this Maer's. Okay, Maer's formula also. So if you have any doubt, then you can comments me, and the next video we can use some process, okay, different process, and using this process we can explain the more application related to the first law of thermodynamics, like process, the isothermal process, adiabatic process, isobaric process, and isochoric process. Okay, so thanks for watching this video. Thank you.